Hi, my name is Lane Osborne, and today I'm presenting to you reverse engineering for a better flashlight. So first off, what our group had to start off with was obviously picking a demographic. Picking a demographic was a huge piece of this presentation, and we chose hikers and campers. And so what we started off with was our proposed flashlight, obviously, which was a pig-styled hand crank flashlight that had LED lights in it. And in our mind, this hikers and campers would need a better flashlight than this, and so our goal was to make a better flashlight than this proposed pig flashlight for these hikers and campers, make it brighter, smaller, more versatile, less noisy, and just all around a better flashlight for these hikers and campers. So setting off, we created a customer needs table by interviewing several different customers. We interviewed all hikers and campers. We interviewed 9 males and 3 females, and then we took the answers that we got there and we added them into a customer needs weighted needs table. So we have the important things first, like needs to be small. It's obviously a huge thing for hikers considering they carry small backpacks and they need everything to pack up really small for them, and that came up 23 times throughout conversation. So that was obviously a big thing we needed to work on when thinking about this flashlight. We have other things like needs to be bright, single hand charging, needs to have a bigger beam. So brightness, that's definitely just something huge. Whether you're in a small tent and you're trying to find your way around, or you're in the woods or in a cave, you need to have a big beam on your flashlight so that it can be bright and you can see long distances and just see with no ease. You should not have to squint when using a flashlight. What we have here though is a cut line, and these were the items that were mentioned a few times, still really important things, but just not enough to really draw our attention too much, and we would address those items last on our list. So once we would come through all of these, if we still had time in the project, we would come back and try to address these as best as we possibly could. So with that in mind, we had to obviously test the proposed pig flashlight, which was this blue flashlight made the hand crank. So we had a light test, an effort to crank test, a noise test, a durability test, size test, and battery test. So as you can see here, we tested it in lux, and it came out to 2710 lux. And when cranking the handle, it averaged out to be about 21 newtons per press. And the noise was less than 91 decibels, which when you add that up, that's not very loud. But if you're out in the woods and you're trying to see nature and stuff, you don't want to have to deal with a noisy hand crank flashlight. The size is shown in the next slide, and it's not too big, but it's not too bad as well. And also another big thing was durability. This blue flashlight was made out of plastic, and so when dropped from only 7 feet, it shattered, and you can see all on the insides and stuff, which you can't be having that when you're out in the woods and dropping your flashlight on the ground in a rock, anything like that, a hard surface. You can't have it be breaking on you. So with that in mind, we moved on to our functional model. So first, before this, we created a hypothetical functional model, which looked exactly like this, except we had one little piece right here called an EME, which would convert the kinetic energy from the Blue Pig hand pump into electrical energy, which would then power the light. This is what we hypothetically thought that the pig flashlight would work like, but once we disassembled it and reverse engineered it, we figured out that there was in fact no EME, and when pumping the flashlight, it went directly into powering the light, which our team kind of felt to be a poor design, and we were kind of confused at why they would do this, considering that everyone thought that when you would crank this flashlight, it would go into the battery life, which would then prolong the battery life and make it easier for everyone to use, when in fact it had nothing to do with the battery life at all. So we created this functional model to figure out how the inputs work and what it outputs, puts light and heat and stuff like that, and just to get a better understanding of how the flashlight works for when we were going to engineer our flashlight later. So something coming up is size. Size is huge with these hikers and campers, like I said earlier, trying to pack it up small. So what we did is we created a flashlight with a little handheld battery module and this little front piece of the flashlight. Now this front piece of the flashlight is special and unique for our design, considering that it plugs directly into this battery module, creating a little handheld flashlight, and you can then, once it's charged up, unplug that and put it into a headlamp so you can have hands-free flashlight. So something different about our design though that you can't see here but you'll see in the future is that we did away with the hand crank idea. It was just too noisy, took too much space, and was too hard to engineer well, we figured, for our hikers and campers, so we bypassed that, took it out, and moved on to bigger and better things. So this is how the battery diagram of our module works. So our module, as you can see here, is a square bit like this, and it has two connectors right here, which is where the flashlight would plug in at. And it would plug in there. You'd have AA batteries in here where you could charge up your flashlight, and then once you're done using it, you can unplug that and the end should be charged, and it would plug in to your headlamp. And right here we have our circuit diagram, which explains how that works when plugging in the flashlight to the end of this, how it will charge up your light so that you can unplug that and use it in your headlamp for hands-free flashlighting. So this is basically just the explaining of our battery and how we have prolonged battery life compared to the proposed flashlight. So finally, we have our final design. So as you can see here, we did away with the hand crank idea. So right here you'll find our headlamp head strap idea, and this is our module, and this is the front piece of the flashlight that's actually projecting all the light. There's 6 LEDs in here compared to the 2 or 4 that the Pig flashlight had, creating a brighter light and a larger beam. And you have our module here, which is smaller, skinnier, and shorter than the Pig flashlight. So you could take off this front piece, plug it in there. You got your AA batteries, as you can see over here, and that would charge up your flashlight so you could use it a little handheld for in the tent or walking around in the woods, just exploring anything like that. And then if you were still on a hike and you needed a flashlight because you realized it was getting a little dark before you could set up camp, and you're trying to set up your tent and you don't have anywhere to put your flashlight, you can just unplug this front piece here, plug it into the headlamp, click the button, and you have yourself an easy headlamp flashlight, and easy to use, should be bright enough. And yeah, so another thing that we touched on was more durable. Durability is obviously a huge factor for this flashlight, considering that the Pig flashlight broke from only a 7-foot drop, being about right here, and is made of plastic. So we made our design out of aluminum, making it lightweight and durable. So you can drop our flashlight from above 7 feet and it will be just fine. It may dent a little bit, but no, you will have no functional problems with this flashlight if dropped. And as you can see here, we have our AA battery spot. With the 6 LEDs, it makes it brighter. With the aluminum, it makes it more durable. And with the headlamp and module idea, it makes it more versatile. In our design, we designed it to be smaller, overall trumping every single benchmark that was set by the Pig flashlight so that we could gain back the market of the hikers and campers. Overall, I feel we were very, very successful with our design and the process we took to overcome these benchmarks by doing away with the hand crank, which did away with the noise, eliminating it to 100%, making it a completely quiet flashlight for nature. Overall, I think this flashlight would do great on the market for the hikers and campers, and I want to thank you all for listening.